Hi again. In this session, we for example, review the linear and nonlinear relationships between variables. Okay. In the first paragraph, we will re-explain how to find the midpoint of the line segment, joining 2 points. So we know normally we have a 2 point. Okay, for example, this point and this point. We have coordinate x1, y1 for the first point and x2, y2 for the second point. How to find the midpoint of this line? Normally, the midpoint of this line has a point, so we want to find its coordinate, abscissa ordinate. The abscissa of the midpoint is the average of the abscissa of the extremum of the other points of the line. Okay, and also the ordinate is the average y1 plus y2 over 2. So it is easy to find the coordinates of the midpoint of a line segment. So normally it is limited. We can find its distance, but the line, no, we can't compute and we can't measure the distance of a given line because a line have an infinity distance. Okay. What about the distance of a line segment? So we can measure the line segment, the distance of the line segment. So normally the distance of the length segment equal to the radical of the sum of the square of the differences between the abscissas and the ordinates. So it is easy, the square root of x1 minus x2 squared plus y1 minus y2 squared. So normally, if we have these 2 points, these 2 points give us the line segment. So normally it is a 4 minus 10 squared plus 3 minus 5 squared, and then we apply the square root to obtain the distance. So it is 2 radical 10. It's easy. Moving on. Normally, all these concepts are on the linear. So we are talking about line, linear. Non-linear, like a circle, for example, parabola, and so on. So normally, non-linear, it is a curve, but linear, it is a line, straight line. So normally, here we are also talking about a linear relationship. We have a line, and in this diagram, they ask us to draw a right angle triangle and find the gradient of the line. What we mean by the gradient? The gradient is the slope, the quotient rise over run. So normally, how to find the slope? If we have 2 points, if we draw any right triangle, or we choose any 2 points, okay, to fix any 2 points, and to complete drawing a right triangle, any 2 points on this line. We can use any 2 points of this line, and we draw a right angle triangle, and we should find the abscissa, or the coordinate of these 2 points. So it is easy, and it is simply to find 2 points on this line. If we fix 2 points on this line and you find the coordinate of these points, normally we can use this quotient, the difference between ordinate over the difference over abscissa. Normally we should adopt the same order. If we use the ordinate of the first point of the second point, so first on the numerator, so in the denominator we should also use the abscissa of the second point before. Okay, so normally it is y2 minus y1 over x2 minus x1. It is the rise over the run, the height over the run, okay, horizontally. Okay, so as we said before, To evaluate the gradient of a line, we always need to find the coordinate of any 2 points of this line, and the gradient is the same. It is called also the slope. Find the gradient of the line passing through these points, this pair of points. So we can, for example, find the gradient. So normally it is y minus y over x minus x. If we start with this one, y minus y, x minus x is easy, okay? Or y minus y and x minus x in this way, okay, to obtain the correct gradient. Find the gradient of the line shown on the right. It is easy to use a graph of a line to find its gradient because it is easy to find, for example, two particular points. For example, we have at this point, easy, the x-intercept where the line intersects with the x-axis, and the y-intercept is the point where the line intersects with the y-axis. In the y-axis, we have 0, 2, because all the points on the y-axis have abscissa equal to 0. 0, 2. So 0, 2, it is a particular point of this line. And all points on the x-axis have an ordinate equal to 0 because they are on the ground, okay? And not on any floor as a height. So normally we have y as 0, 1, 0, minus 1, 0, because the origin is here. Origin with abscissa equal to 0 and ordinate equal to 0. So this is the minus 1. Minus 1, 0 is the second particular point of this line. So we, at this level, we have 2 points are very, very, very sufficient to obtain and to calculate the gradient. Normally, y minus y, x minus x. 2 minus 0 is 2. 0 minus minus 1 is 1. So 2 over 1 is 2. Or we can use it in the reverse or the opposite order. And asking about drawing and sketching a line, it is sufficient. You should know it is sufficient to find the 2 particular points. If we have this point and particular point of this line, so we join this point with the straight line to obtain the line. So it is easy to sketch the line. We need only 2 points that belong to this line. For example, to draw the line y equal to 7 minus 3x. How to find 2 particular points? We draw it is a small table like x and y, okay, with two empty entries with 2 other columns. Normally, we choose any x for example, for x equal to 0. For x equal to 0, so we substitute in the equation of the given line with x equal to 0. Minus 3 by 0 is 0. So normally y equal to 7 by minus 0. So the y equal to 7. So normally the x values, we can choose them, but the y values are related to the x values with respect to the given equation of the line. So normally we compute the y values. So if we choose that x equal to 2, so minus 3 by 2 is minus 6, so 7 minus 6 equal to 1. So also easy. Also easy to, for example, put them on the repair. So normally 0, 2 is, for example, here is the y-axis, here the x-axis, 0, 2. So normally 0, 2, so it is a point on the y-axis, 1 and 2. So normally it is the first point, particular point, 0, 7, 0, 7. So normally 0, 7 is here, approximately here, 0, 7, and 2, 1, x equal to 2, so y equal to 1, 2, 1. This is the second point. So normally we draw a straight line joining these 2 points to obtain the line that we want. So it is easy. About the exercise 7, to verify that a point lie on a given line, it is very sufficient to find out if its coordinates verify the line equation or not. So normally we have these x and y. So we put x and y on, we substitute the value of x and y in this equation. If the equation is well verified, is correct, so normally in truth statement, so we say that the point lie on the line. So normally here, if we substitute x by 4 and y by -3, we'll obtain a statement say that -3 equal to -3, so it is true statement. So normally we say yes, the point lie on the line. Circle, we should know that circle, it is a non-linear relationship, or are given, it is any circle is given by a non-linear equation. Non-linear equation, because easily we can say that because x appears with square and y appears square and not with x power 1 and y with the power 1. We'll see more information about that and the upcoming new chapters. Okay, normally the equation of a circle is given by x minus the abscissa of the center squared plus y minus the ordinate of the center column squared, all squared, equal to the radius squared and radius squared. So normally if this asks us to find the equation of a circle have a center 0, 0 and radius radical 7 units, so normally we can easily substitute hk by 0, 0 and the radius by radical 7. Normally radical 7 squared is the 7. It is not a radical 7 squared, it is 7. Okay, it is only 7 because the radical, the square root and the power 2 are inverse operation. They cancel each other to obtain finally 7. So x squared plus y squared equal to 7. Thank you for listening. Bye bye.